In this video, we're going to talk about Chapter 4, Section 1, Angles. Now, Chapter 4 deals with trigonometry, and obviously, anytime you talk about trig, you want to start off with angles itself. So, real fast, an angle is generated by rotating a ray about its fixed endpoint from an initial position to a terminal position. So right here, I have a picture that I drew. So I'm going to paste it. And here's what an angle looks like. So first things first, all right? And I'll highlight as I talk. First, we have our initial side, and then we have our terminal side. This right here is called the angle. Now, if we go counterclockwise, we call this a positive angle. So angle 1 is a positive angle. However, if we go the reverse, so if we go from the initial side to the terminal side, but we go in the opposite direction, then this is called a negative angle. Angles 1 and 2, since they both start at the terminals, since they both start at the initial and they end at the terminal side, but they do it in two different ways, these are called coterminal angles. So I guess I can write it like this. Angle 1 and angle 2 are coterminal. And that's, like I said, that's just because one is a positive angle, the other is a negative angle, but since they both start at the initial and end at the same terminal, coterminal angles. All right? Now, angles are normally given letters or names. So the symbols that we use for angles are going to be theta, phi, alpha, beta, even gamma, and if you notice, these are all Latin symbols. There is no, hey, this is what you always do. It's normally we use these symbols right here. In fact, the one that you're going to see a lot is theta and alpha. Those are the two biggies. But you can also use capital letters A, B, C, D, and so forth to represent any type of angle you want. Now, the one thing we do have to be concerned with it when we're talking about angles is how are we measuring the angles? And what I mean by that is this. We have two ways that we measure angles. The first way is degrees. And then the second way would be radians. Okay? So the thing you got to remember is you got to look at what you were given. Because even though you may be doing the math correctly, when you go to substitute this into your calculator, you may get it incorrect because you are not in the correct mode. So that's going to be a big thing here. So make sure you're in the correct mode for your calculator. So let me show you real fast. So we're just going to minimize this and get our calculator out here. All right, and what I mean by mode is when you click on the mode icon, all right, notice a little bit down, we have on the third row, we have radian, and then we have degree, okay? Traditionally, calculators are put in radian mode. However, sometimes you got to put it in degree mode. So my advice to you is this. Whenever you do a problem and you get an answer, if it's not correct initially, before you think you did something wrong, maybe go back and look and see what mode your calculator is, and then go ahead and type it into your calculator again, because that could make the difference for everything. If you do that and you're still getting the answer wrong, and chances are maybe something's wrong, and that's okay. We're learning this, but I don't want to see you get all frustrated when it's a calculator issue and not a human issue, if that makes sense. All right. So let's go back and let's start looking at some examples where I'm going to be converting from degrees into radians and radians into degrees and so forth. So the first thing we're going to do here is let's express 2.13 radians as degrees. Okay? So remember, pi radians is equal to 180 degrees. In fact, we're going to be looking at this thing called a unit circle that looks kind of like this. And we're going to get all these different measurements right here. And in this first quadrant, if we know what the first 4 of them are, then we know what all of them are. We just got to kind of use this quadrant here as our guide, okay? But pi radians equals 180 degrees. So remember, anytime you want to convert something, you write down what you're given first. Then we're going to go ahead and we'll convert by multiplying. We want radians to eliminate. We want radians to reduce. So the radians will go in my denominator. Degrees, I'll just put like a little circle there. For degrees, will go in the numerator. I know there are pi radians in 180 degrees. So all I have to do here is just take 2.13, multiply it by 180. And that gives us 383.4 degrees. All right? So that's exactly how we do this. It's not overly difficult, all right? It's just remembering like where to put things. Let's do one more here. We'll go the other way now. Let's express 90 degrees as radians. All right, well, remember, you always start with what you're given. 90 degrees. We're going to multiply this by degrees goes in the bottom, radians goes up top. So we know there are pi radians in 180 degrees. And when you multiply this out, you're going to get 90 initially. Here, I'll write it out initially. Remember, our degrees will reduce. So we get 90 pi radians over 180. However, when you reduce this, you end up getting pi over 2 radians. And this is very special. So you definitely want to remember that one because we're going to be using that a lot. Now, there is a third way that we measure angles. I got to be honest with you, though. I've never, ever used this unless I was teaching. That being said, that doesn't mean we don't use it out in applications. I know it's used everywhere in like robotics and boating and everything, but it deals with the form of degrees minutes. So here's an example of degrees, minutes, and seconds. So first, let me show you what this looks like. We may have an angle. And let's say this angle is, now we'll go 45 degrees, 23 minutes, 14 seconds. So this is the degree measurement right here. All right. And to convert this to decimal form, so convert 45 degrees, 23 minutes, and 14 seconds to decimal form. All right. All we really have to do is just remember what this actually means. All right. For example, we know come on, erase. There we go. We know there are 60 minutes in 1 degree. Okay? So when we think about this, this is going to mean that this 23 is nothing more than just 23 over 60. That's really what it means. And this turns out to be point, and I'm going to round this to 2 decimal places, 0.38 degrees. Now, in 1 degree, there are 3,600 seconds. Oh, sorry, wrote that backwards. There we go. And 1 degree, there's also 3,600 seconds. So these are the conversions that we would need. So we would take 14 over 3,600, and that's going to be 0.004 to 3 decimal places. You can use your calculator to do this. And then to kind of bring everything together, all we have to do is just rewrite this as 45 degrees. And then, well, let me be technically honest here. We're going to take this result and this result, which is in degrees, and we're going to add them together first. So put a 0 there, 483 with a decimal. So this is really 45.384 degrees. And that's all this is. It's just another way of measuring angles. All right. Chances are I'm going to put a couple of these on the homework, but I don't even think I would test you on something like this. Okay. The last thing we're going to talk about is standard position of an angle. So standard position of an angle. And what I'm going to do here is I'm just going to write out the definition. I'm going to pause the video, write the definition, then we'll talk about it. All right, so here's the definition of the standard position of an angle. And all it says is if the initial side of the angle is the positive x-axis and the vertex is at the origin, the angle is said to be in standard position. So all that's saying here is this. Here's our rectangular coordinate position right here. If we assume that the positive x-axis is the initial side, and then we have an angle that comes up like this, this angle right here is standard position. Now, I'm not going to draw all of these. Your book has a picture of all of them. So let's go ahead and let's just look at your text real quick. So here we have example 4, angles in standard position. And as you can see here, part A matches up with figure 4.8a and stuff like that. All right, so this is a 60 degree angle in quadrant 1. This is a 130 degree angle in quadrant 2, 225 degree angle in quadrant 3, 340 degree angle in quadrant 4. All right, now the last two, they're not tricky. You just got to think about it. So since we are going in the opposite direction, this is a negative angle. However, the positive x-axis is still the initial side. So this is still a standard position angle. It's just a negative angle, and it's in the third quadrant. And finally, with part F here, this is a standard position angle of 90 degrees. And we call this and I can't even say this word, it's going to be hard, quadrantal angle, since its terminal side is the positive y-axis. So if your terminal side is any one of the axes, so if it's the positive y-axis or the negative y-axis or the positive x-axis, we call that a quadrantal angle because its terminal side is one of the axes. And that's going to be it for this video. See you in the next one.